11.8 now? I think so.
Voice, hello, hello, hello. Okay, we're here. Alright, back from fucking Illinois, yo. We got stuff happening. Is this right? I think I might have just started that. I think that's what happened. I think I just finished and I didn't want to start another because I was still on a plane. Okie doke. The weird breathing shit is what it is. It's a part of me now. Do some push-ups real quick and then walk in. I just finished Death Stranding 1. Great game. Oof. One hand only from now on. I'll do 2. I'll do a negative. One positive and negative, and then one negative. Gotta get better at one arm push-ups. Oh god, I'm gonna have to poop at some point. I ate Takis yesterday, and I have more of well, it doesn't matter. I have more of them, but I haven't been eating them in a long time. Been saving my money. But I impulsively bought some yesterday, and shouldn't have, but now I'm gonna have fucking diarrhea all the time. I still have a shit ton. I'm probably still gonna eat them too. But okay, so yeah, generic programming. I'm gonna do just learning, so I'm gonna do an hour and a half of learning, and then so I'll go to bed at 11. Hour and a half of learning, and then no test today because I had to finish Death Stranding, so I didn't have time. Plus, I had to cook and other shit. So okay, so seems like generic programming is the act of using templates so that I can write code that behaves that behaves no matter what data type it gets, or at least programming that handles different data types, like a function that can behave for different things. So like I can have an equation, and to avoid rounding errors when possible. Yo? I thought I heard like echo or something weird. Okay, and to avoid rounding errors, it can handle integers, and it will treat integers as themselves. It will not convert them to floating point values. But if it gets a floating point value, then it'll deal with it as it is. So, meaning that there's a primary template that we call, and with our argument, the primary template will, during compilation, will create a ow. I fucked my arm up at work somehow. I don't know how. Or shoulder, rather. It will create a specialization, which is instead of the placeholder type name, the generic thing that we're doing, the template piece, it's going to create another, basically an overloaded function, where instead of it being a placeholder, it is specifically the data type that the call has. So if I call this generic function template with an integer, let's say it doesn't have any other parameters, or let's say it does. It normally has just a type name and a float, and I call it with an integer and a float. It will create a version of the function, a specialization, with an integer and a float for the parameters. That way the compiler can see my call and boom, call that version of it because I'm using these arguments. Because we know when we call a function that has multiple versions, multiple overloads, then it calls the overload that most closely matches the parameters. So, in terms of generic template programming, it actually generates a whole function to identically match this shit. So we can have another version, and I call it with a standard string and a float instead of an int and a float, because the template has a type name, so any data type, a placeholder, and a float. So I could call it with a standard string and a float. However, that process by which the compiler and the template generates a specialization, a specific version of the function. It does not check to make sure that that specialization is valid. It simply says, hey, you are paying my store in Italian cash. I don't know if we take Italian cash. I'm just the cashier, compiler. So I'm going to try and accept that cash. I'm going to go and put it in its own little Italian cash box. But at the end of the day, or at the end of this transaction, I'm going to bring my fucking manager over, the rest of the compiler, the actual call to that specialization. And my manager's going to check and see, can we actually use this Italian cash? Maybe the Italian cash is the integer. Cool, we're good with an integer. That works here. We are doing stuff to this placeholder type, which ends up being an integer variable or integer value, whatever, and we're incrementing it and decrementing it and adding and subtracting and doing different things to it and multiplying and returning it and calling it as a parameter to a fucking Mersenne twister to seed it and all these different things. Or we're seeding a seed sequence and all these different things. But maybe you give me some Taiwanese currency, and that's a standard string. And in the actual transaction, in the specialization, the logic is that I am adding and subtracting and doing stuff to a standard string. Well, it turns out that I actually can't do that to a standard string. It's not valid for that type of data, that data type. So I can't use this Taiwanese currency, unfortunately. So I'm going to say, hey, I created a little box. I put your currency in my little box, but I can't actually use it. I created some shit because that's what the call said. That's what the customer had. So I accepted it, but I can't actually use it. I can't compile it. Therefore, it's invalid, and the compiler is going to yield an error. If we're doing like a C-style string, that's different than a standard string. A standard string is some sort of object that you can't just increment and decrement. It seems like a standard string is its own object. When I create a standard string, it's not a reference or a pointer to something that I can apparently add and subtract from. Unlike a C-style string, which apparently is a pointer to a character that's just in memory. It's apparently a constant character, something like that. So a character that's unchanging, some piece of memory. So when I have a standard string and I increment it, then normally we're pointing at the start of that, I guess it's an array or a list, a sequence of characters, instead of pointing to the first one, or maybe for you, the first one. Oh, I added one. I'm pointing to the next one. Oh, and then I subtract one. I'm pointing back to the first one. Oh, and I add 3. I'm skipping 1, 2, 3 characters, and now I'm pointing here. Different things. I don't know exactly how that works. That's my understanding so far. I have a little bit more of understanding of pointers back from when I was using C for like a couple months. But I don't want to rely on that because I probably have some total, I'm ignorant about what's actually true. Excuse me. So, yeah, there are some arguments that the generically programmed function template can use because there's logic in it. And maybe that logic varies. Maybe we have a standard string specialization, and in this case it has to be an explicit specialization, meaning that I didn't let the template create a specialization, create a version, create an overload because of the call. I actually did that myself. I said, hey, here's a template, a function template, this regular thing that receives calls and generates shit using it. Instead, I actually created that specialization myself. That way, if we call this function with a standard string, it doesn't say, hey, function template, make a standard string version specialization. It already actually has it, so we just call that straight away. So, we're calling it straight away, which means I can actually change the logic. So, for example, if I did, maybe if I had like an attack function, and it was a generically programmed function, so a template function, or a function template, something like that. And normally we call it, and we pass it a type name that we can do shit with numbers. So it increments the type name or does something to it. Normally we pass it a value. Okay. So normally we pass it, and maybe in general we pass it the name of the character, like some sort of object. So a character or an enemy. Maybe these are different data types. These are different objects, classes. And then I pass it an integer. And then we say, hey, we output the name of the thing that's doing the attacking, and then we output the damage. But maybe we have a standard string version or some other specific version, and we don't pass it the numbers. We instead just pass it the name of the thing that is attacking. And then maybe I have a namespace somewhere with other values that correspond to that standard string, to those names. So I have one version where I actually have to pass it a name because it doesn't already know it. I pass it, hey, here's this new character, like let's say it's the player character, and I say, hey, I'm going to pass in the player character, and I'm going to pass in some specific new number because I'm changing whatever the character's attack is. It's not already known. It's not stored somewhere. I actually have to explicitly put it in a call. But for something like a skeleton, for example, maybe skeleton already has skeleton attack damage somewhere else in another namespace. Well, maybe in that case I can say, hey, just pass it skeleton. And then it finds that standard string in that namespace, finds its corresponding attack damage, and then boom, it's good. So maybe we use the template to handle any new shit the character does. Maybe we're like the character's trying to do shit that we're not expecting, so we handle that. But when the character does something or something else does something we do expect, then we can pass it a different argument and we can call it, and then we can call, or not call, but we can execute different logic. So I can have a function template that generically creates these different specializations, but the logic is all the same. It's just that the things that it's operating on, the parameter that it's operating using, might differ in terms of data type. But I can explicitly create one of those specializations. That way, the logic actually differs. So in the placeholder and integer version, so any of these different types, so it could be different types of integers, different types of floating point values, other stuff like that, integral values, whatever. It does this, whereas maybe there are these other parameters that I explicitly handle to do something else instead. Or maybe there's like a function that determines whether the attack is successful. And if the attack is successful, then we call the if the hit is successful, then we call the apply damage. And normally the apply damage takes the character and the damage. But in case it fails, we instead pass it a standard string that says failure. So instead of passing it failure and then it doing some numerical stuff with failure, instead it's explicitly looking for failure. Failure already fits an existing specialization. It doesn't generate shit, it already exists. I hard-coded it. And in that case, it just fails and it doesn't actually do the attack. So if we hit, then we call, we create a new specialization and we handle the hit. If we miss, we call an explicit specialization that already exists in code that I made myself explicitly line by line, and that handles the miss. So it's the same function, but it differs depending on what the result is. So I guess you'd have to say it would be a void function. The hit would be a void function, and it would, if it hits, it calls the damage function and passes it these arguments. Otherwise, it calls and passes it these arguments. And when it calls these arguments, that's when the generic programming kicks in, and it generates a specialization and then does that. And like as an example, I guess we could do of what I was talking about. So we'll have, do we call it applied damage? I guess we can. We can just say void apply damage and it'll just output different stuff. So it'll apply damage and it takes a type name, or sorry, it takes a T something and yeah, sure. Okay. And it says, and all it does is it outputs applied X damage. Okay. But we can have an explicit version. We can continue this existing template like this. And we can say void apply damage. But this time it's specifically, I need standard string here. And in this case, to make it more optimal, we can also do string view. That way we can pass standard string values cheaply. And in this case, it takes a standard string view and it is a standard string view X. And in this case, it says if X is miss. Oops, we don't need to, what do we call this? We don't need to nest any of this shit. We can have it on the same line. So we just do an if statement and then boom, we don't have to have this complex statement, this block. We can just say missed. Attack missed. Applied no damage. Okay. Okay, cool. So, if we do anything else to it, if we give it an integer, if we give it a float, if we give it a 0, if we give it a 1, if we give it a character. And in this case, I kind of want this to be an integer always. So what I'm going to do is, I wish that would just do this. We're going to static cast to an int. That way we have a specific, well, do we do float? I guess we could. Or I guess we'll do double. X, okay? That way if we pass this a character and it's fucking lowercase a, it'll do 97 or 65, I think maybe it is. It'll do some amount of damage, whatever. So this is always going to be a numerical value, but if it sees a standard string, well, if it sees a standard string, I guess, or a standard string view maybe, then it will instead say it's a miss. So I could have a standard string and we'll just call it hit value and we'll initialize it to be sure hit, or we'll just say miss, and then we will simply call apply damage, hit value. Okay. The problem here is that hit value is a standard string, so it is trying to convert this. If we instead change this to be a standard, or this needs to be a standard string. So it's seeing, hey, this isn't actually a standard string. If I pass it a standard string view called view hit value, and we initialize it to be hit value, and then we do view hit value, it's still doing that. Interesting. Oh, well, it's because if we make this a standard string, then hold on. Oops. These are not matching. What was happening? The specialization string view string is not a specialization. So it seems like it's basically saying that our syntax is wrong. This is an explicit specialization, but the template type here is not matching. It's not actually being used. So there's no template to use. But in this case, and what if we just said this is a string view from the beginning, and then we just say hit value. And this is a string view that just watches miss, wherever the hell it is in memory. And we call it does missed, because we're explicitly calling this specialization. And we can look at it here in the debugger and step into real quick. Boom. We see that this continuation of the template, this explicit specialization of the, I guess the primary template, is called. Just like if we say it's a standard string instead. Oops. And we call it directly this way. Excuse me, it's cool. But, excuse me, if we do it with an integer, if we do it with a float or a double, sorry, if we do a character, if we do in here, and yeah, so this is automatically, we don't have any non-template versions. If we had non-template versions of this for the character, then it would be prioritizing that. I mean, sure, we could explicitly say, hey, this is a character. Take this and convert it to a character if applicable. But usually we want to use template type deduction or template argument deduction, something like that, where it says, hey, here's the argument, it's type character. Cool. Call the character version. Oh, we don't have a specialization. Therefore, create a character version where this type name T becomes a character, meaning this becomes character X. So when we call this version, or when we call this guy, it will say, hey, I already have a specialization for a character. Cool. But that's just extra syntax. We may as well just use type deduction by leaving it like this. So in this case, these are all going to apply damage. Why? Because these calls are with an integer, a double, and a character. None of those are standard strings. Therefore, the primary template generates specializations. It will generate one of these guys for the int version, one of these for the double, and one of these for the character. And then, boom, it will call those explicit versions. If we instead did void template to continue, void apply damage, character X, we'll just do standard character output, character received, no damage dealt. Cool, like this. Oops, what is happening here? Oh, we didn't do it. Character. Oops. Character this received. What is happening here? Okay, it's cool. I don't know why it was having trouble with this. In this case, it's saying, hey, oops, character this space received. Character C received, it'll do this. So instead it's saying, hey, all right, we're calling it. What type is this guy? Oh, it's a character. Okay, so we're basically calling apply damage character, and then with a character value. It's the same type, so it doesn't matter. This is fine. So it's gonna look, hey, do we have a character version? Oh, we do. Nice. Call this guy. Cool. I think we're good. They don't take much longer to write. Oh, yeah. So, I mean, like if I had some sort of formula that handled a bunch of different gravity type stuff, I mean, I could simply just calculate the force. Oh, fucking template or whatever. We'll just do it real quick. Template, type name T, sure, void print, print force, and then it's a TX, and this is some value or whatever, and then we'll just say, double acceleration. I kind of did something like this yesterday, and then it fucking we'll just do Okay, so we have some standard character output, and then we're just going to output, force is, we'll just say x times, time space acceleration, which is this, and whatever. We'll just do x times acceleration. Okay, no, it's fine, but there's a linker issue because we don't have main. What is the thing called that calls main? It's like a gateway or some shit. I don't remember. Whenever you call a program, it initializes or it starts main in the beginning. If it doesn't have main, it basically sees, hey, main is a thing. Cool, the compiler's happy. But then when the linker tries to actually go and find the definition of it, basically main is forward declared somewhere and called whenever you click the program, I guess, in the exe or something on some piece of code. And then it goes to find wherever the hell, whatever file main is within. Well, when it looks in here, it doesn't see main anywhere. It says, hey, yo, there's no fucking definition. Therefore, the linker complains. So, in this case, we're just going to do print force, and then whatever. I'll just print it a character. And then, this will be interesting. Yes, let's see. Yeah, so no, hold it. Type name x and double. So, if we said print force, and we said 1, hold on, what is happening here? Template tightening this. Oh, oops, I only passed it one parameter. This doesn't have a default argument. I'll just make it a default argument, sure. Let's just say it's gravity. Cool. So in this case, it's fine. At first it was worried because it's saying, hey, any possible function that gets generated by this guy has 2 parameters. Therefore, the signature is print force, type name something, double something. Okay? Well, if you're calling it with only a 1 thing, well, the template can't generate one that matches. So in this case, what the fuck? Cool. It sees 1. Oops. I meant character C. I should have compiled first. C, so it's saying C times something is whatever it is. Let's say C is about 100. Yeah, C is 97 in this case. Oof, right? Isn't that how that works? So we say, or not 97, I guess it's 99 if 97 is, or is it 97? I don't know. The math seems like it's not, yeah, that's what I thought. Okay, is it 99? Yeah, it is, because 9 times 8 is 72. That's why we got a 0.2 at the end. Yeah, makes sense. Cool. Okie doke. Because 97 is lowercase a, and then 65 is uppercase a. So if we did uppercase, or lowercase a, or fuck me, bro. I said uppercase a and then did lowercase a. Okay, cool. And it's 65, so it's basically 65 times 10, which is about that. Cool, makes sense. So, we're good. Yeah, I think I understand all the stuffs for now, or what I could know. Yeah, it doesn't take very long, and it handles a bunch of different stuff. I could pass it a float, or a double, or a fucking who knows what. And as long as it's actually valid, and the shit that we're doing with the value is able to be done to that value, the compiler's happy. Oh, and the drawbacks could be compilation times. So if we have 5 different calls to something, or let's say we have 50 different calls to something, and we somehow call it with 50 different data types. I don't know 50 different data types. It's 8, 16, 32, 64. Float, double, bool, character, unsigned int, 8, 16, 32, 64. Maybe fast ints, maybe. Maybe there are yeah. What else? Oh, I mean, sure, yeah, everything else. Standard string view, characters, fucking pass it a Mersenne twister, why not? Pass it a random device. Pass it all kinds of different shit. Well, as long as we can do the same shit to each one of those, then we're cool. Or if the generic, if the generically programmed primary template has conditions that are able to check the data type of the template parameter it gets, then maybe it has a condition that says, hey, if it's this type, do this. If it's this type, it does this. If it's this type, it does this. Or you could just say, do the same shit. And if you need to do anything explicitly, you're cool. Yeah, if you need to do different stuff anyways, you could just make overloads. And then you're only calling one thing. You're not calling one thing and then doing a bunch of conditions. So sacrifice compile time for processing time. Every time you call it with a different thing, it doesn't check to see if it's these 49 types and, oh, it's type 50. Do this, finally, after evaluating 50 conditions, individual branches. Then behave. Instead, behave instantly. Just call the one that's appropriate. Cool. So, drawback could be compile time. Drawback could be some sort of shitty assumptions by saying, by calling it with something, because the templates don't check for semantic behavior. So if it's returning an integer and you're passing it an unsigned integer and you're decrementing it, you're going to get overflow. If it's a super large, or it's an integer and you're passing it super large values and you're incrementing it or adding to it, then you're going to get negative values if it's returning a signed value, a signed integer. What else? If you're incrementing or decrementing booleans, well, you're probably going to get a value that's not what you expect. Yeah, I think those are the main things. So basically, just be careful. Make sure your shit handles what it needs to. And if you have specific types you need to disallow, like saying, like deleting a version of a function, disallowing it, so that if we call apply damage with a standard string, and a standard string and a standard string, instead of a standard string and an integer or a floating point value, or any other version that's valuable, if we don't pass it a name and a number, then we can delete that version. So if we pass it two names, we can delete it. If we pass it you could do it a couple ways. You could, if you only wanted to take a couple certain types, well, you could just not call the shit you don't want to call. Or you could disallow them by explicitly making a specialization for all the ones you want, and then deleting the template. That way, if it doesn't have an explicit specialization, it disallows whatever it's calling. That way, everything that could be possible that you would want to handle properly, well, is already in the code. Anything you didn't expect or didn't want is disallowed. Somehow it's been 30 minutes already. Okie doke. I'm gonna go to sleep a little earlier. I'm gonna go 20 minutes more. I meant to do an hour and a half. I know, I'm a pussy. But I am on sleep debt because my plane got delayed when I was flying back on Sunday. Today is Tuesday, which means my sleep yesterday was ass. My sleep before the yesterday was ass, Sunday to Monday. And then my sleep last night was okay, but I had to stay up, I think, a little extra because I was trying to finish Death Stranding, and then I finally got to a part where I could save and quit. And that means I still have some sleep debt, both from yesterday and the day before. So, in order to remedy my sleep debt, I will go to bed in 19 minutes. So cool, these could save us time if we want to use multiple different data types and do the same shit. Or we want to disallow specific things, or we want to handle something specifically different from another way, and maybe we want to do the same thing for multiple data types. So, if we want this generic code to work the same way for different data types, cool. If we want to Update a game character's name. Maybe we want to use C style strings. Maybe we want to use standard strings or string views or any other type of list of characters. Well, we could just replace the name of the character with whatever the hell we're getting instead of having to have a C style string version. I don't know how we even do that. I guess a const character pointer, a standard string, a string view, and a something else. Cool. Yep, crazy amount of code, so slower compile times. I don't think compile times are super important right now because, I mean, if compile time is effectively loading shaders, then sure, maybe it actually is hard. It seems like that's a runtime thing though. It's taking a lot of stuff that exists and bringing it into memory live, which maybe takes longer than just compilation. Could be wrong, but if compile times are always okay, then maybe it doesn't really matter that we do it that way. Okay. So it could be a bunch of code because we have a bunch of different types that we're taking. Crazy looking borderline unreadable messages. I mean, so far I haven't seen anything like that. I mean, all you have to know is that the template parts, the little shit within the angle brackets, tells you what type of specialization it was looking for, or that it called and had an error in, or other stuff like that. So if it had an issue there, it would be cool. I'm curious if we had an assert and we called it and the value was too low, what it would say or where it looks, or where it tells us the error is found at. So if we say we include C assert, and we include, and I think maybe that's all we need. Excuse me, template type AMT, sure. Void do thing, TX, assert, X is greater than 10, cool. Nice, it's fine. Do thing, 10. It's not greater than 10, we're gonna get an abort. Oh, and let's actually ignore this real quick, and we're gonna say, we're gonna assert this, and X must be greater than 10. That's what's failing. What if I did an inline character in here? I don't know if I have before. Okay, didn't change anything. So we'll just go back to this. Okay, where is it located? It still just says the line, so it's fine. I don't see anything mentioning the template. Seems like it's okay. I don't see any crazy errors so far. I've been able to understand them so far. It'll say something about like specialization doesn't exist. Like if I had a template for some type of thing, but then I made a specialization and the specialization didn't match, meaning that like the template type parameter or the template parameter wasn't matching the type of the specialization. So the type of whatever template parameter it's supposed to have doesn't actually match the real type of the template parameter. So like if we say there's a function and it's in angle brackets an integer, but then we have a float for the placeholder type, it'll say, hey, these two types don't match. No go. Okay. Power and safety. Power because we can do less shit, and safety because there's less shit to maintain. We write the thing one time, we handle the stuff there, and we call it a day. We maybe have to make some more specializations to handle other things. We might have to disallow, delete certain functions. But in the end, we have a primary template that generates code for us depending on the calls that it actually gets in the code. i.e., we can avoid violating the don't repeat yourself rule, or at least best practice, whatever. That way we get more maintainable shit. Less prone to semantic errors, we should be cool. Use the menu where we need type flexibility. Okie dokie. We create regular functions, and we say, oh shit, I'm returning this product no matter what type of operands I'm using. Oh, I want to return a product for integers just like I do for floats, or doubles or int 8s, or int 16s, or 64s. Cool. Proceed. Generic programming. Let's go. Okay. Yep. Did some maximums to multiple different template types. So we could do this by like get a function going real quick. Oh, we'll include input and output. And we'll just do sure. And we'll have template type name T, type name Q, oops. TX, QY. What if we did QQ? Oh, is it okay? Yeah. Oh, because then, well, we can actually shadow a template type. Noted. Because the compiler will prioritize. Ow, my shoulder. Internal rotation hurts. Oh, right there. It prioritizes the identifier over the type. So we'll do QY. And return, we'll do a little ternary action real quick. So we'll do okie doke. Is X greater than Y? If it is, return X. Otherwise, return Y. And in this case, we will just output whichever one it is. And then we can, let's call this guy and see what's happening. We're good. And we're going to just call do thing. And we'll call it with 3 and 4.0. Okay, so we're calling it with an integer and a double. Cool. So it's basically making an explicit specialization of int and then double, int and then double. Cool. Call this guy and it returns 4. Okay. 2 different data types. They don't necessarily have to be 2 different data types. They could just happen to be both integers, just like that. That seems straightforward enough. So we could do this. The problem here, actually no problem here yet. We could do 1 and 2. The problem though is if we do 1.5 and 1, it'll say, hey, it probably doesn't match this guy because these two are supposed to be the same type. Well, actually, in this case, it's actually fine. It just so happens that these are integers. Hold on. Oh, well here, we only have one type. It's saying that this is a type of a T, this is a type of a T. But if we do a 1.5 and a 1, well, T is a fucking whatever. But which one is it? Oh, we don't know. We have 2 different types. Well, there's an error. Boom. Why? Oh, here we go. Ternary operator. Cool. An integer and a double. Well, which one are we going to do? Sure, in this case, if x is less, we return y. 2 is less than this, we return y. We return 3.5. The problem, though, is, well, it can only generate functions for calls with the same data type parameters. Ooh. Let's see what happens if we do that. So if we say, and we just say sure. And we call do thing with these. Uh-oh, well, it's actually not even a crazy error. It's just saying, hey, the types in the argument are a double int. Well, these must be the same type. Our argument doesn't work. It's different types. So it's saying, hey, there's no matching overload, meaning that, hey, there's no other version of max that takes an int and a double. And it's saying that this guy is ambiguous because I don't know if it's actually ambiguous. It's just that it doesn't know what to do. It's not found. And I guess it could be, well, it should be generating one that matches both of these. Yeah, but they're different types. Okay. It can't, yeah, because it has two different types here. So it's saying, hey, the specialization needs one type, and these two are both the same type. It'll say max, and then in angled brackets, integer or whatever, and then integer, integer. Well, which type do we deduce that is shared amongst them? Well, none. One's a floating point, one's an integer. Two different types. Int and a double, yes. Oh, so it'll check things maybe in different orders. So it could say, hey, well, one, there's no overload that takes these. Okay, we also have a template guy here. Let's see what happens. If I explicitly called it with some bracket action, then it would only consider the template. And it might not say no matching overload found. But for me, it said no matching overload found. So it might still say that. Oh, I'm mega tired. I gotta just go to bed. Sorry.